Hi, in this video I'm going to demonstrate how to determine the molecular formula given percent composition of a chemical compound. To do this, we're going to follow a couple of steps. Notice how in this practice problem I've got three percentages of three different elements involved in a mystery compound. Okay? Now in the problem it says an unknown compound is found to contain 40% carbon, 6.7% hydrogen, and 53.3% oxygen. Okay, and then it tells us the molecular mass of the compound, which is 60.0 grams per mole. But we're going to worry about that later. Right now, we're just going to deal with this percent composition. Because if you've learned how to make percent compositions, you basically need to convert the number of moles in a compound to mass, and then divide the mass of an individual element by the total mass. Well, in this case, where we're trying to figure out molecular formula, we're going to do the reverse of that. So in the case that we're given percent compounds, what I'm going to do first is assume a 100 gram sample of compound. Now if that's true, then in our 100 gram sample we should have 40.0 grams of carbon, we should have 6.7 grams of hydrogen, and 53.3 grams of oxygen. Okay? So what we need to do to convert this to a formula is convert each of these gram values into their mole values. Okay, we're going to do that using their molar masses. Okay, let's start out with carbon. So step 2, we're going to convert each gram value into a mole value. Okay, so I'm going to take my 40.0 grams of carbon, for example. Now I've got a periodic table pulled up right here. Carbon is 12.011 grams per mole in molar mass. Okay, so I know there are 12.011 grams per 1 mole of carbon. Okay. For the sake of time, I'm going to do these calculations at the end. So let's just go ahead and set up our next conversion. So if I have 6.7 grams of hydrogen, well, according to our periodic table, hydrogen is 1.0079 grams per mole. And we're going to do that conversion later as well. And then the final conversion, 53.3 grams of oxygen. Well, we know that for every 15.999 grams of oxygen, we have 1 mole of oxygen. Okay, so let's go ahead and bring up a calculator so that we can do these conversions. Okay, I'm going to type in 40.0 grams divided by 12.011 grams per mole for carbon, and I get 3.33 moles of carbon. Next we have 6.7 grams of hydrogen divided by 1.0079 grams per mole of hydrogen. When I do that, I realize I have 6.647 moles of hydrogen. And last, we have 53.3 grams of oxygen divided by 15.999 grams per mole of oxygen, which gives us 3.33 moles of oxygen. Okay. Now notice, if you look at these numbers real close, you'll see some patterns start to emerge. These numbers are the same. In other words, the ratio of moles of carbon to moles of oxygen is a 1-to-1 ratio. You'll also notice that the moles of hydrogen is about double those of carbon and oxygen. Okay? So if we were to write a formula for the simplest ratio of the elements in this compound, we could say that, well, for every 1 mole of carbon, I have 2 moles of hydrogen and 1 mole of oxygen as well. So this right here, this is what is called the empirical formula. It's the empirical formula because it is the simplest ratio between all of the elements involved in this compound. But we're not quite sure that it is the molecular formula. Okay? So I'm going to keep my steps going over here. What we just did, we computed, actually I'm going to scratch that. What we just did, we determined the smallest whole number ratio between each element in our compound. Okay. Fourth step, we determined the empirical formula. Our final step is to determine the molecular formula. Now the way we do this, up here they gave us the molecular the molar mass of our mystery compound, which is 60.0 grams per mole. Okay? So 60.0 grams per mole, that would be the molar mass of our molecular formula's elements added up. So to figure out basically what the multiple is to get up to our molecular formula, we need to take the molar mass of our empirical formula, CH2O. Okay? So let's go ahead and figure out the molar mass of our empirical formula. So I've got 1 carbon. I'm going to take 1 times 12.011. That's the molar mass of carbon. I've got 2 hydrogens. I'm taking 2 times 1.0079. These are grams per mole, by the way. And I've got 1 oxygen, which is 15.999 grams per mole. I'm going to add all these up, and we're going to figure out what the formula mass of our empirical formula is. So my calculator, I'm going to type in 12.011 plus 2 times 1.0079 plus 15.999. So my formula mass for my empirical formula is 30.0258 grams per mole. Okay? Now notice that if we take this 30.0258 grams per mole and we divide it into our 60.0 grams per mole of our molecular compound, of our molecular formula, we're going to see how many times our empirical formula goes into our molecular formula. Okay? And it's not really hard to see what that multiple is going to be. Okay? You don't even need to use a calculator. So what's 60, roughly, divided by 30? Well, that's just 2. What that means is that if we take everything in our empirical formula times the subscripts by 2, we should get our molecular formula. Okay. So that is how you do these types of problems. If you have any questions, feel free to email me. Thanks so much. We'll catch you in our next video.